My name is Ignacio Labrador Pavón, and I'm representing here the work package 6 of Hexa-X-II, in which we are addressing the smart network management and orchestration enablers towards 6G. Okay, going directly to the point, in this figure you can see an introduction of our Hexa-X-II smart network management and orchestration enablers. As you can see, we have 11 different enablers, which are associated to 5 different tasks that we have defined in our work plan in Hexa-X-II. We have this task 6.1, you have on the screen, programmability, flexible network configuration and monitoring with 2 different enablers. Then we have task 6.2, trustworthy management and integration fabric with 2 enablers as well. Then task 6.3, interdomain and intercomputing management with also 2 enablers. Task 6.4, sustainable and trustworthy AML-based control, in this case with 3 enablers. And finally, task 6.5, real-time zero-touch control loop automation, also with 2 different enablers. Okay, as you can see, also these management and orchestration specific enablers combined with other enablers being defined in other work packages here in Hexa-X-II that you have probably seen in previous presentations. All of them are intended to be used to design the, let's say, the end-to-end Hexa-X-II system blueprint. Okay, let's go now into more details about each single enabler. We will start with enabler 1, programmable flexible network configuration. Basically, this is about including the SDN technology in the 6G architecture. We know SDN is not something new. Of course, it is a key enabler already in the 5G technology. However, we consider SDN should continue being part of the 6G system as well, because of course, we will still consider necessary to continue interacting in a programmable and flexible manner with the network infrastructure components, and also relying in well-defined standards. However, we consider also some innovations associated to this SDN technology. One of them is the alignment with the cloud-native approach, which is, let's say, common denominator for the 6G architectural design, as it was already introduced in our previous Hexa-X-I project. Also the design of interfaces for new devices, and we dedicated focus on network disaggregation and aligning the SDN architecture with the cloud continuum concept. Then, on the other hand, regarding the monitoring and the telemetry part, this is enabler number 2. Yes, we also know this is a fundamental part already in 5G and in previous generations, of course. But as with the previous enabler 1, we think this should be considered as a main enabler also towards 6G. The main aspects we are considering here are regarding real-time data processing, as you can see there, to quickly solve performance and security issues, and also regarding the data collection to feed AI/ML systems. For example, incorporating the possibility to include user-defined metrics and not just a predefined set of metrics to be monitored, and also considering the monitoring system as a kind of pervasive monitoring system, integrating metrics from different network domains, for example, combining data from network and application domains to facilitate correlating data in order to trigger more intelligent orchestration actions based on AI/ML models. Regarding the integration fabric, this is an implementation of the ETSI CSM integration fabric concept, which is oriented to enable the integration and the interaction of the different components of the management and orchestration system. It is also in line with the cloud-native principles and with the service-based management architecture concept, enabling the connectivity of loosely coupled and fine-grained services. By means of this, what we are trying to explore is the refactoring of the connectivity model of the various components of the management and orchestration framework. It provides distributed cloud-native deployments with very dynamic registration and discovery features in a multi-stakeholder scenario. The plug-and-play concept is the overall guiding principle here in order to provide very dynamic and very agile service innovation, for example. A similar concept to this integration fabric was already proposed also in our previous Hexa-X-I project to perform the functions of the APIs administration and exposure. However, here in Hexa-X-II, we are addressing also multi-site setups, and we are working also in the implementation of a prototype regarding this. On the other hand, regarding enabler 4 on the right-hand side of the slide, trustworthiness is of course something that is clear we need to consider in 6G, which is envisaged to be composed of many interacting stakeholders. In this regard, we are targeting 3 different aspects mainly. The first one is resource controllability separation, going beyond role-based access control, defining a more granular access control to targeting authentication, authorization, and auditability. Then, on the other hand, we are considering user-centric service provisioning with applicability to 6G specific devices and going beyond today's policy-based solutions, and that way making SLAs more elastic and dynamic as well. Finally, we are considering also trust management by relying on the level of trust assessment functions, for example. Okay, moving on. In this slide, we have the interdomain and the intercom management enablers. Enabler 5 is specifically about the multi-cloud management mechanism, as you can see there, targeting the unified management and orchestration of multi-cloud, multi-cluster resources that could be deployed on different platforms or administrative domains. In the envisaged 6G end-to-end system, we envisage the deployment of distributed services and the provision of distributed applications in multiple clouds to better satisfy the service demands, privacy, and security needs. So as we can see here, hierarchical decision-making solutions are being considered, as well as the usage of AI/ML techniques for the optimal resources allocation and for making predictions as well regarding management and orchestration mechanisms, among others. Also, for federation, we are investigating also the adoption of distributed ledger technologies. Then enabler number 6, here we are considering the orchestration mechanisms for the computing continuum with main focus on integrating the so-called extreme edge domain. The targeting of this extreme edge domain was already introduced in the previous Hexa-X-I project as well, meaning that domain beyond the mobile network operator on domain and including even the end user devices. The objective here is to integrate that domain as part of the network continuum, so to deploy network service components on it as well, which is considered quite challenging since the infrastructure resources in that domain can be highly heterogeneous. They can be also asynchronously connected or disconnected since they are not in well-controlled premises. They can be mobile devices, they can be error-prone, or they can be devices with very limited computing capabilities. The extreme edge domain itself can be very huge, with millions of devices in a cloud-native scale. So we consider this is one of the main innovations towards 6G regarding management and orchestration. In this Hexa-X-II project, we continue exploring this concept in the context of this enabler number 6, trying to address those challenges associated to the management and orchestration of both resources and service components on that extreme edge domain. POC, a prototype, is also being prepared regarding this concept. Okay, moving on, this enabler 7 is about including the sustainability aspect in the AI/ML-based control processes, mainly focusing on monitoring the energy in the different stages of the MLOps workflows. For example, to monitor the energy consumption or the training or the inference stages in order to make more accurate decisions on when or where to perform that training. Also considering sustainability targets in the AI/ML-driven optimization processes, for example, for the network services components placement by prioritizing the placement of those infrastructure resources by green energies. We are also investigating solutions in connection with the intent-based management processes oriented also to save energy while implementing those intents, and considering also federated AI/ML algorithms also oriented to save energy. Yes, I was commenting, we are considering also federated AI/ML algorithms also oriented to save energy, distributing the training workloads, again, prioritizing the network power with green energy sources. Okay, regarding AI/ML-based control, we have also enabler 8 to introduce trustworthy related aspects associated to this. In this regard, we are investigating different technologies, specifically regarding the security aspects, for example, analyzing the vulnerability of the AI/ML-driven management and orchestration mechanism. Also regarding to the privacy of the data, even in multi-party scenarios, considering techniques such as differential privacy or homomorphic encryption, among others. And regarding to the explainability of the AI/ML management and orchestration decisions, which can be quite relevant in what regards certain management and orchestration actions that may affect the QoS or the quality of the experience of the services in execution. On the right-hand side of the slide, you can see also our enabler number 9, targeting the network digital twins concept. In our case, digital twins are seen as a way to improve the control of the network by providing a sort of environment where validating the management and orchestration mechanism and decisions before applying them on a real environment. Specifically, our work here is focused on defining the control and the monitoring flows for generating and updating the twin. The objective here is not just to simulate the execution environment, but to create a virtual replica of the real environment using massive amount of data. We are exploring also the usage of graph neural networks, as you can see on the slide. And this is the last slide, which is about the automation concept through closed loops. Here you can see this is split into enablers. One of them regarding the individual closed loops governance. This is enabler number 10. And another one targeting the multiple closed loops coordination by means of enabler number 9. These enablers are indeed the services assurance states, and to guarantee the network performance, and of course to guarantee also the compliance with the service KPIs. In general, the main idea associated to these enablers is to enable the deployment in a very dynamic way of different management and orchestration closed loops, which can be adapted to particular targets at different levels, for example, network level, infrastructure level, or service level, and using AI/ML techniques wherever it could be necessary, for example, to perform prediction tasks associated to these closed loops. A critical point regarding this is the coordination among multiple, that could be many, closed loops, which is targeted specifically by this enabler number 9, in order to identify potential conflicts and to decide how to mitigate them where possible. There are several approaches that we are investigating, for example, the delegation or the escalation, for example, in case of hierarchical closed loops. Also the collaboration among different closed loops, and also the possibility to share the knowledge also among different closed loops, among other options as well. Okay, this is basically an overview of what we are investigating and proposing so far in Work Package 6. Of course, this is ongoing work, and you can find more details in our deliverables, which are available in the Hexa-X-II website. That's all from my side. Thank you very much.